Inside China's mega factory, a finished car rolls off the assembly line every 30 seconds. You heard that right. 2 cars per minute, 120 cars per hour, around the clock without stopping. That means in the time it takes you to watch this video, this single factory will have produced enough vehicles to fill a parking lot the size of 40 football fields. And it's not just one factory. China has dozens of these mega factories operating simultaneously, each one moving at this incomprehensible speed. But here's what makes this even more mind-bending. There are almost no humans on these assembly lines. Thousands of robots are doing the work, controlled by artificial intelligence, moving in perfect synchronization. This isn't manufacturing as you know it. This is something entirely different. This is the future of production, and it's already here. Let's step inside and see what you're actually looking at. Stepping into the impossible. You're standing at the entrance of a mega factory in Shanghai or Chongqing or somewhere in central China. The doors open and you step inside. What hits you first isn't the noise, it's the sheer scale. This isn't a warehouse. This is a city unto itself. The ceiling stretches so high above your head that it disappears into shadow. The floor extends in every direction farther than you can see. The space is so massive that they've had to install its own internal roads just to move equipment and materials between stations. And then you see them. Thousands of robots. Mechanical arms moving with terrifying precision, welding sparks exploding in synchronized bursts, parts flowing across the space on automated conveyor belts that never stop, never pause, never slow down. The robots aren't moving randomly. They're moving in perfect choreography. Like a mechanical ballet where every dancer knows exactly where to be at every moment. You start walking along the assembly line to understand the flow. At the first station, massive stamping presses are crushing flat sheets of metal into car body panels. These aren't small machines. Each press weighs hundreds of tons. The sound is deafening, a rhythmic crash that repeats every few seconds as another panel is formed. The speed is almost incomprehensible. Panels are produced so fast that the output looks like an endless river of metal flowing downstream. Then those panels move to the welding section. Hundreds of robotic arms are positioned along the line, each one waiting for its moment. When a body shell arrives at the right position, dozens of welding robots activate simultaneously. Their torches igniting in a coordinated explosion of subsidias. Sparks. Each robot knows exactly where to weld, how long to weld, how much pressure to apply. The welds are perfect every single time. No variation, no human error, just absolute mechanical precision repeated thousands of times per day. You move deeper into the factory, and the complexity multiplies. Autonomous guided vehicles, basically driverless carts, are moving parts between stations without any human guidance. Computer vision systems are scanning every component, checking for defects that a human eye might miss. Robotic arms are installing engines, transmissions, suspension systems, each operation taking seconds. The vehicles are progressing through the factory like items on a cosmic assembly line, each one moving inexorably toward completion. And the pace never slows. One car every 30 seconds. Another one arrives at the next station. Another one moves to the painting area. Another one enters final assembly. The rhythm is relentless. There's no downtime, no waiting, no inefficiency. Everything flows with the precision of a Swiss watch, except this watch produces 2 cars every minute. You're watching something that shouldn't be possible. You're watching manufacturing at a scale and speed that defies human comprehension. But this factory isn't magical. It's not running on wishes or luck. It's running on engineering. Incredible, sophisticated, perfectly coordinated engineering. But the engineering alone isn't what makes this work. There's something else controlling everything. Something that can see, analyze, and adjust in real time. The invisible intelligence. You need to understand that what you're actually watching isn't just mechanical precision. It's artificial intelligence, orchestrating thousands of decisions every single second. This factory has a brain, and that brain never sleeps, never gets distracted, and never makes mistakes. Throughout the facility, thousands of sensors are constantly measuring, monitoring, and analyzing. Computer vision systems with cameras and laser scanners are positioned at every critical point along the assembly line. These systems aren't just recording what's happening. They're actively analyzing the quality of every single component as it moves through the factory. And they're doing this at superhuman speed. When a robot welds a car body, sensors immediately scan the weld to verify it meets specifications. The scan completes in milliseconds. If the weld is even slightly imperfect, the artificial intelligence system catches it instantly. The production line can halt that specific vehicle without stopping the rest of the line. The defective component gets removed and reworked. Everything else continues flowing at the relentless pace. This real-time quality control is revolutionary. In traditional factories, defects might not be discovered until late in the production process, or even after the car leaves the factory. By then, you've wasted hours of labor and materials on a vehicle that needs to be reworked anyway. In China's mega factories, defects are caught and corrected within seconds. The factory self-heals as it produces. But the artificial intelligence is doing something even more sophisticated than quality control. It's predicting problems before they happen. Sensors on every machine are constantly transmitting data about temperature, vibration, pressure, and wear patterns. Machine learning algorithms are analyzing this data in real time, looking for signs that equipment is about to fail. The system can predict with remarkable accuracy when a robot arm is going to break down, when a conveyor belt bearing is about to wear out, when a stamping press needs maintenance. Maintenance can be scheduled during planned downtime instead of causing unexpected shutdowns. This predictive maintenance saves enormous amounts of money and keeps the factory running at maximum efficiency. A breakdown in a factory producing one car every 30 seconds costs thousands of dollars per minute in lost production. The artificial intelligence systems are worth their weight in gold just by preventing those breakdowns. Then there's the coordination layer. The factory is producing multiple vehicle models simultaneously on the same assembly lines. Some are sedans, some are SUVs, some are electric vehicles, some are plug-in hybrids. Each one requires different components, different assembly sequences, different configurations. The artificial intelligence is managing this complexity, ensuring that each vehicle gets the exact components it needs, that each robot performs the exact operations required for that specific vehicle model, that nothing gets mixed up. The coordination is so precise that a specific vehicle model can flow through the factory, picking up exactly the right components at each station, having exactly the right operations performed, and emerging at the end as a completed vehicle with zero errors. Multiply this by 2 cars per minute, every minute, around the clock, and you start to grasp the scale of the coordination problem that artificial intelligence is solving. But artificial intelligence and robotic precision are only half the equation. The other half is equally crucial. The parts have to arrive at exactly the right moment. If parts are late, the production line slows down. If parts arrive too early, they pile up and consume valuable factory floor space. Everything has to arrive in perfect synchronization. And that's where the supply chain coordination becomes almost terrifying in its precision. The supply chain choreography. You need to step back from the factory for a moment and think about what's actually required to feed this machine. A car that rolls off the assembly line every 30 seconds requires components arriving at that factory in perfect synchronization. Think about that for a moment. Not approximately on time, not close enough, perfect timing. A typical car has around 30,000 individual components, not 30,000 different types of components, 30,000 actual physical pieces. Some are sourced internally from other factories owned by the same company. Some come from external suppliers. All of them need to arrive at the right moment so the assembly line can use them immediately. Chinese megafactories accomplish this through something called just-in-time manufacturing taken to extremes. Suppliers don't stockpile inventory. Instead, they produce components according to real-time demand signals from the factory. The factory sends a message: "We need 200 door panels in the next 4 hours." The supplier manufactures those panels and ships them immediately. They arrive at the factory dock, get sorted by the autonomous guided vehicles, and move directly to the assembly line where they're needed. This creates an incredible efficiency advantage. The factory doesn't have to devote massive amounts of floor space to storing components. Inventory sits in suppliers' warehouses instead of taking up valuable real estate, but it also creates massive vulnerability. If a single supplier is late, the entire production line faces delays. If a supplier's quality drops, Defective components reach the factory and cause cascading problems. Chinese automakers have solved this problem through vertical integration. Instead of relying on hundreds of independent suppliers, many Chinese companies own their own supply chains. BYD, one of the largest EV manufacturers, owns battery factories, steel mills, semiconductor plants, and component manufacturing facilities. This means they control quality from the raw material stage through final assembly. They can coordinate timing with absolute precision because they're coordinating within a single company. Western automakers rely on networks of independent suppliers. This creates flexibility and competition that can drive down costs. But it also creates coordination complexity that China has largely eliminated through vertical integration. When you own your entire supply chain, you can optimize the whole system instead of optimizing individual pieces. The supply chain coordination is so precise that trucks are arriving at the factory dock in carefully timed sequences. Each truck carries components for a specific batch of vehicles. The components are offloaded, sorted, and moved directly to the assembly line without ever sitting in storage. The timing is so precise that if you were to watch truck arrivals over a week, you'd see them arriving in almost rhythmic intervals. But all this precision creates a risk that nobody wants to talk about. If anything goes wrong in the supply chain, if a supplier has a fire, if a transportation route gets disrupted, if bad weather prevents component shipments, the entire factory can grind to a halt. There's no buffer. There's no safety stock. Everything is optimized for flow, which means there's no margin for error. And yet, these factories keep producing 2 cars every minute. The coordination is so sophisticated that they manage to keep the flow going despite all the potential failure points. But there's something even more remarkable happening. The factory isn't just coordinating parts, it's coordinating the actual manufacturing sequence based on customer demand, the demand-driven assembly line. This is where it gets truly mind-bending. The factory isn't producing a standardized car that then gets customized later. The factory is producing vehicles that are already customized for specific customer orders. A customer in Beijing orders a specific configuration of a specific vehicle model. That order goes into the production queue. Within days, sometimes within hours, that exact vehicle is being built on the assembly line. This is possible because of the factory's flexibility. The assembly line can be reconfigured on the fly. A robot that installed a standard interior in one vehicle can be reprogrammed to install a luxury interior in the next vehicle. A stamping press that created body panels for a sedan one moment can switch to creating panels for an SUV the next moment. The factory isn't built around a single product, it's built around flexibility. This creates an enormous competitive advantage. Western factories are typically optimized for producing a specific vehicle model in large batches. You build 10,000 of Model A, then retool for Model B. The retooling takes time and money. Chinese megafactories can jump between models and configurations at a moment's notice. Customer demand pulls the production schedule instead of the factory pushing a standardized product onto customers. The demand-driven manufacturing means that vehicles being produced right now are already sold. They're not sitting in inventory waiting for customers. They're not being produced on speculation. The factory is converting customer orders into finished vehicles at a rate of 2 per minute. By the time a car rolls off the assembly line, its owner has already been waiting for weeks, not just ordered it that day. This demand-driven approach also means the factory is incredibly efficient at managing inventory. There's no overproduction. There are no excess vehicles sitting in storage lots. The entire system is optimized around producing exactly what customers want, exactly when they want it. From the customer's perspective, they get a customized vehicle. From the factory's perspective, they're manufacturing at maximum efficiency. The speed at which this happens is staggering. A customer places an order. That order gets scheduled into the production queue. The factory adjusts its configuration. Within weeks, the vehicle is complete and ready for delivery. For a company producing multiple vehicles per minute, the ability to go from customer order to finished product in just a few weeks is an incredible advantage. But there's something even more fundamental about the way these factories operate that gives China a competitive edge nobody's talking about. The cost equation nobody can match. You need to understand the economics of what's happening. A mega factory producing 1 car every 30 seconds is achieving something that traditional factories can't match. Economies of scale that are almost impossible to comprehend. When you're producing 2 cars per minute, your fixed costs, the cost of the building, the robots, the equipment, the infrastructure, get spread across an enormous number of vehicles. A factory producing 1 million vehicles per year can amortize its capital costs across that entire output. If it costs $5 billion to build the factory and equip it with robots, that's only $5,000 in capital costs per vehicle. Spread that across 100,000 factories worldwide, and the capital cost per vehicle skyrockets because those factories produce far fewer vehicles. The labor advantage is equally staggering. A mega factory producing 1 car every 30 seconds might have only a few hundred human workers. A traditional factory producing the same number of vehicles might need thousands of workers. The mega factory's labor cost per vehicle is a fraction of what traditional manufacturers pay. Even though robots require expensive maintenance and replacement, the cost per vehicle is still lower than paying human wages. Then there's the energy efficiency. A mega factory is optimized for flow. Everything moves continuously, without stops and starts. The heating, cooling, lighting, and power systems are optimized for continuous operation. Waste is minimized. Material scrap is reduced because of the precision manufacturing. The cost per vehicle is lower across the board. And vertical integration multiplies these advantages. When you own your entire supply chain, you eliminate the middleman markup. You control quality from raw materials through final assembly. You can optimize the entire system instead of optimizing individual pieces. The total cost of ownership for a vehicle is lower than it would be if you were buying components from external suppliers. All of this creates a pricing advantage that's almost impossible to overcome. A Chinese automaker using a mega factory with vertical integration can produce a vehicle for significantly less than a Western automaker relying on traditional factories and external suppliers. That cost advantage translates directly into lower prices for consumers or higher profit margins for the company. This is why Chinese automakers are starting to dominate global EV markets. It's not because their vehicles are superior, though many of them actually are. It's because they have a structural cost advantage that comes from their manufacturing capabilities. They can undercut Western competitors on price while maintaining healthy profit margins. They can invest more in technology and innovation because their lower manufacturing costs free up capital. They can take market share from competitors and still make more profit per vehicle. But the mega factories represent something even larger than just a cost advantage. They represent a completely different approach to manufacturing that's redefining what's possible. The future is already here. What you're witnessing inside China's mega factories isn't just incremental improvement over traditional manufacturing. It's a fundamental rethinking of how cars are built. Western factories are still using assembly line concepts that haven't changed dramatically since Henry Ford invented the assembly line 100 years ago. Robots have replaced some workers, but the fundamental structure is the same. Vehicles move through stations in a line. Workers or robots perform operations. Vehicles move to the next station. Chinese mega factories have abandoned this model entirely. They're using flexible manufacturing systems where robots can be reprogrammed in seconds, where supply chains are perfectly coordinated, where artificial intelligence is making real-time decisions about quality and efficiency. They're using vertical integration to control the entire production process, from raw materials through final assembly. They're using demand-driven manufacturing to produce exactly what customers want without overproduction or waste. This manufacturing approach creates advantages that go beyond just cost. It creates agility. When a new vehicle model needs to be introduced, the mega factory can adapt in weeks instead of months. When customer preferences shift, the factory can adjust production mix without expensive retooling. When quality issues emerge, the artificial intelligence systems catch them immediately instead of discovering them weeks later. The speed is a manifestation of this new approach, not the goal itself. 1 car every 30 seconds is impressive, but what's really impressive is the underlying flexibility and efficiency that enables that speed. The factory is simultaneously producing multiple vehicle models, multiple configurations, with just-in-time component delivery, real-time quality control, predictive maintenance, and demand-driven assembly. The speed is almost a side effect of optimizing for efficiency, flexibility, and quality. And this is just the beginning. As robots become cheaper, as artificial intelligence becomes more sophisticated, as supply chains become better coordinated, these mega factories will only get faster and more efficient. The speed might increase to 1 car every 20 seconds. the human workforce will shrink even further. The cost advantage will grow. Western manufacturers are watching this happen and realizing they've been left behind. Remodeling existing factories to operate at mega factory efficiency would cost tens of billions of dollars. Building new mega factories would take years and require completely rethinking how production works. By the time they catch up, Chinese manufacturers will have already moved to the next level. You came here thinking you'd learn about car production speed. But what you've actually learned is that China has completely reimagined what industrial manufacturing looks like. And they didn't just reimagine it. They've already built it at scale, and it's producing vehicles at speeds traditional manufacturers never thought possible. The moment manufacturing changed forever. You came here thinking you'd learn about car production speed, but what you've actually witnessed is something far more profound. The moment when industrial manufacturing fundamentally transformed. Western factories are still operating on assembly line concepts that haven't changed drastically in 100 years. Robots have replaced some workers, but the structure is essentially the same. Vehicles move through stations. Operations are performed. Vehicles move to the next station. Chinese megafactories have abandoned that entire model. They're using flexible manufacturing systems where thousands of robots can be reprogrammed in seconds. Supply chains are coordinated with military precision. Artificial intelligence is making real-time decisions about every aspect of production. Vertical integration controls the entire process, from raw materials through final assembly. Demand-driven manufacturing produces exactly what customers want, without waste or overproduction. This isn't incremental improvement. This is a complete reimagining of what's possible. One car every 30 seconds is impressive, but it's just a visible manifestation of something deeper. Factories that are simultaneously flexible, efficient, and scalable in ways traditional manufacturers never achieved. And here's what should terrify Western competitors. This is just the beginning. As robots become cheaper, as artificial intelligence becomes more sophisticated, as supply chains become better coordinated, these mega factories will only accelerate. The speed might increase to one car every 20 seconds. The human workforce will shrink further. The cost advantage will multiply. Western manufacturers are watching this unfold and realizing they've been left behind. Retrofitting existing factories would cost tens of billions of dollars. Building new mega factories would take years. By the time they catch up, China will have already moved forward again. You came thinking you'd watch a video about car production. You're leaving understanding that China has completely reimagined industrial manufacturing. They didn't just reimagine it, they've already built it, scaled it, and optimized it. And right now, at this very moment, one car is rolling off a Chinese mega factory assembly line. Then, another. And another. 2 per minute. 120 per hour. While traditional factories are still trying to figure out how to compete, Chinese mega factories are already redefining what industrial manufacturing looks like in the 21st century.